I watch a lot of YouTube videos, and one channel that I've been subscribed to for a few years, Technology Connections, has a ton of great content and shouldn't really need an introduction from this fledgling channel and its tens of viewers. In a recent video entitled "The Clever Feature That Makes Cheap Heaters Safe and Why They're Actually Dangerous," the topic hit home, or rather hit work for me, and I thought I would share some clips and add my perspective as a workplace safety advocate. I highly encourage you to watch the full video linked in the description, as well as much of the other content of this channel. To use a clip from the original video,
I love nothing better than when more people understand more things more completely. You've probably heard from all sorts of people that electric space heaters are dangerous things which are likely to cause a fire. And it is true, they can be dangerous and they can start fires. However, likely not in the ways you imagine they can. Even this cheap plastic heater, which cost less than 20 bucks, has multiple safety devices which make many of the dangerous scenarios you might imagine nearly impossible.
safety is designed right into nearly all products these days. Gone are the days of lawn darts, but I'll insert a brief disclaimer from this video.
The written warnings on a space heater, or really any product, should never be ignored. They were written in blood.
Keep in mind that safety warnings, regulations, and standards are, in fact, written by the injured, maimed, and killed. This is no more true at work than it is at home. I've been in a variety of environments professionally and have had a lot of conversations about the use of space heaters in office, retail, production, and other environments, and have discouraged their use for many of the reasons highlighted in the Technology Connections video. Since I can't explain it any better, this clip highlights the concerns that I generally cite when I have those discussions.
The larger reason space heaters are known to be a fire hazard actually has nothing to do with the heaters themselves and everything to do with your home's electrical wiring. Most of these things which are on the market, regardless of type, will put out 1500 watts of heat, and that requires 12 amps of current at 120 volts. That is the maximum allowed to be drawn continuously from a typical 15 amp circuit, and that means plugging in a space heater becomes an instant stress test for whatever circuit it's on, and that can reveal electrical issues you didn't know about, and potentially with awful consequences. For instance, if there's a very slightly loose wire nut in a junction box somewhere in your walls, or maybe there's a connection point somewhere that's got a little corrosion on it, that's usually not a problem. While it might introduce a little bit of electrical resistance at that point in the circuit, if all you're using that circuit for is charging a laptop or a phone, not much current will go through that connection, so the issue won't ever present itself. But if you plug a space heater in, that can quickly change. That marginal connection point will start heating up because of the large current the heater is drawing through the circuit. And if it heats up too much, that can start a fire. This is made even worse by the fact that technically a space heater should be the only thing on a 15 amp circuit if it's going to be drawing 12 amps. But in real life, it's going to be sharing that circuit with some other stuff, perhaps a TV and a sound system in the living room or a desktop computer in a bedroom. That means when the heater's running at its full power, you're really pushing that circuit, and so if there are any problems with the wiring, they're more likely to become an issue. But I don't wish to fearmonger. That scenario is realistically quite rare. The wiring that's in your walls mostly doesn't get touched unless you're doing remodeling or something, so spontaneous development of issues, while that can happen, is quite rare. However, the receptacles that you plug stuff into, including a space heater, those things get touched all the time, and each time a plug is inserted and then removed from a receptacle, a teeny tiny bit of wear occurs. The springiness of the contacts inside there can weaken, and if the outlet is really worn, it might barely be able to hold on to a plug. Receptacles like that are primed to become a major issue when you plug a 12 amp load into them and let it rip, and they are a major reason electrical fires start when people use space heaters. A poor connection between the plug and receptacle can introduce enough electrical resistance to make the plug extremely hot, to the point of melting wires and burning insulation. If you have loose receptacles in your home, they really should be replaced, which, by the way, is quite easy to do, but you're going to have to look for your own information and guidance there. But then, even with a perfectly cromulent electrical system with everything in hunky-dory tip-top shape, there's the problem of extension cords and power strips. Although it is sometimes inconvenient, a space heater should always be plugged directly into a wall outlet. No splitters, no power taps, directly into a wall outlet. Extension cords, power strips, and all those adapters and whatnot are not built to the same standards that actual receptacles are. So although those products may technically be rated to pass more current than a space heater needs, their often poor construction means each individual connection might not be so great, and it introduces an element of risk which you might as well just not introduce.
Power strips are used everywhere in business, in particular where there are workstations with computers and other electronic equipment. It's uncommon for buildings to be set up with direct wired plugs that accommodate the power needs of all equipment, except in the most purpose-built facilities. And even then, configurations and equipment needs change all the time, and rewiring the facility is not always feasible or simply isn't part of the plan. I've made a point to a few IT professionals over the years about power strips they're forced to use when setting up workstations. I explained that power strips can probably handle much of what they are plugging in, but what worried me in a professional environment was what else ended up being plugged in over time by others. Space heaters being of the most concern. Many don't have an understanding of the uncommon dangers of overloading a circuit, and I would end up with examples like these from time to time. What I hope to parrot by sharing these clips here is not only the dangers of certain use cases of space heaters, but also that a lot of safety, in particular in the workplace, is about dangers that don't generally exist, or at least not to the same degree, in the home environment. To stay on topic, your circuits at home are unlikely to become overloaded with normal residential equipment. But install something like a mini fridge on one side of a bedroom and a space heater on the other, and the circuit that supplies these receptacles can easily become overloaded if the conditions are right. This is so much more likely in a work environment with needs, layouts, and conditions changing regularly. There is an old joke about checking accounts that may be analogous. A customer goes into the bank and complains that they bounced a check. The teller says, "Your last 2 checks overdrew your account." The customer pulls out their checkbook and says, "I can't be overdrawn. I still have checks left." Just because there is an open plug on the wall or power strip doesn't mean you have capacity left. Please keep this in mind and remember to check out the full video and all the other content on technology connections.
We aren't so scared of objectively dangerous things when we understand what those dangers actually are and how we can avoid them.
Life is risk. Manage it well.